Hi everyone, my name is Miss Connolly. I started making some videos for my 5th grade class and decided to make it public, and then some parents started asking me to do other grade level content. So here I am teaching different grades and exploring. I hope that these videos are helpful. Please like, subscribe, and share. Let's keep every kid learning during these crazy times. Today I'm going to go over some 2-digit plus 2-digit strategies that are taught in 2nd grade. So one of them was learned in 1st grade and reviewed in 2nd grade, and then we add some more strategies. And so again, this is just for 2-digit plus 2-digit, and the 3-digit videos will be coming later. Okay, so we're going to get started with 32 plus 49. And in the video that I just posted with 1st grade edition, adding 10s and 1s, we're going to go over that real quick. So in 1st grade, students started adding by place value, which means they were adding all of the 10s, then adding all the 1s, and then combining them. So the representation that's used in the curriculum that's taught at my school represents the 10s place with strips of 10. So if we have 3 groups of 10, we have 1, 2, 3 strips, and this represents 10, 20, 30, and then we use singles here. Okay, so these strips represent 10 singles all together. To draw them quickly, we draw one long line. Okay, if for 49 to represent it, we would look at our 10s place and say the digit 4 represents 4 groups of 10. 1, 2, 3, 4. So 10, 20, 30, 40, and then 9 singles. 1, 2, 3, 4, 5. 1, 2, 3, 4. There's my 9 singles. Okay? So the beautiful thing about addition is that when we break up numbers into 10s and 1s, we can recombine them any way we want, and we're still going to get the same sum. So what happens is the students start thinking about all the 10s at one time. 10, 20, 30, 40, 50, 60, 70. So they're starting to think about 30 plus 40 is 70. So they took the digit in the 10s place, they knew that stood for 30. The digit in the 10s place here stood for 40. And then we combine 30 plus 40 is 70. So the next thing that students do is they think about 2 plus 9. They're going to combine the digits in the 1s place. So 2 plus 9, they know is 11. So just to clarify what's happening, they did 30 plus 2 plus 40 plus 9. They know that order does not matter when we're adding. No matter what order we do this in, we're going to get the same answer. So what they're doing is taking the 30 and the 40 first, combining them, then taking the 2 and the 9, combining them. And then what they're thinking about in their head when they add 70 plus 11, in their head they're thinking 70 plus 10 is 80 plus 1 more. So this is what's happening in their head. 70 plus 10 is 80 plus 1 more is 81, and that's where the 70 plus 11 happens efficiently up in their brains. Okay? Parents, take note, there's no standard algorithm going on right now. Okay? They are thinking about groups of 10, how easily it is for them to add a group of 10, and then they're adding the leftover 1 single down here. Okay, so that strategy is called adding by place value. They added the 10s and the 1s. Some teachers call it that, but just so you know, this strategy extends into later grades, and they add hundreds, 10s, and 1s. So adding by place value is the correct name for the strategy. So students start with that, but then we want to push them towards efficiency. So we want to teach them some more efficient strategies. So we have a couple different things that students can do. I'm going to use the same exact numbers, okay? And the next strategy I'm going to go over is called keeping one number whole. And keeping one number whole is really important because we end up using it when we multiply, we end up using it when we're adding and subtracting mixed numbers. So keeping one number whole is really important as a concept to understand. So what we're going to do is we're going to think about the 2 add-ins that we have. We have 32 and we have 49. When I think about what number I want to keep whole, I want to think about doing the least amount of work. And since order doesn't matter in addition, I can keep 49 whole and add 32. So 49 is a larger number, so if I keep that whole and I don't break that one up, it's less work for me to break up the smaller number. So that's what I'm going to do. I'm going to start with 49. I'm going to keep it whole. I'm going to illustrate this many different ways right now. So I'm going to put 49 on my number line, and I'm going to put 49 here, and I'm going to think about how can I add 32 to that. So what we introduce to students is called the hundreds chart. So this has been hanging up here. It's really important to talk about your student about what they notice in the hundreds chart because there's a lot of things going on. So I'm just going to go to 49 here, and I'm going to add 10 just so we can think about what's happening. So if I start with 49 and I add on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you see where I landed here on the hundreds chart? I wonder what happens if I add 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you see what's happening here? When I add 10 and I count by ones, I'm ending up right underneath here. So let's think about what's going on. I'm thinking about 49 plus 10. If I was thinking about this with my strips and singles, I would have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'd have 49, and I'd be adding 10. There's the 10. Did anything happen with the singles over here? No. Only thing that changed when I added a group of 10 was the number of groups of 10. I used to have 4 groups of 10, and now I have 5 groups of 10. But this number, oops, unless you erase something with your finger, this number is not changing, okay? Just the tens place is changing. So 49 plus 10, we get to 59. And then we think about, how many times do I have to add 10 to 49? Well, we look in the tens place, and we know that we have to add 3 groups of 10, or we're adding 30. So let me erase this here. And so we're at 59. I'm going to illustrate it down here also. So on the number line, we added 10, 49 plus 10. The ones place doesn't change, just the tens place. And you'll notice that 0 there is very important. Always smiling when we're working with tens. Then from 59, I'll add 10 more. Okay? We know the only digit that's changing is going to be the tens place because we're adding a group of 10. Nothing's happening to those 9 singles. That should be a little bit bigger. So what we just did was we kept 49 whole. We added our 3 groups of 10, and students are starting to think about, oh, I know what happens. Only the tens place is changing, not the ones place. And so then once you add the 10, 20, 30, then the students will add 2 more. 80, 81. So that's called keeping one number whole. And then I broke up the other number by place value. So let's look at what that looks like on the hundreds chart. If you're practicing addition at home with your kid, you can just whip up, actually it took a long time if you're trying to be like straight and perfect, but you can whip up a hundreds chart for them and they can practice adding here so they can get used to what's going on. So let's say I start at 49. Watch how I use the hundreds chart to add. Plus 10, plus 20, plus 30. Again, plus 10, plus 20, plus 30, 31, 32. So students will start to discover as they're adding groups of 10 that the ones place doesn't change, just the tens place. 40 plus 10 is 50. The 9 does not change. Plus 10 is 60, plus 10 is 70, and then they can go counting by ones. So this is set up purposefully to help students see that when you add a group of 10, the ones place does not change, only the tens place. This is how we would do this on the number line, and if your child was completing it with equations, I have a lot of caps going on right now. If they were completing it with equations, 79 plus 2 is 81. So that is called keeping one number whole. We broke up the other one by place value. If your student is ready, and some students are, they might just go like this. They might say, I know 49 plus 30 is 79. They might already be thinking about 40 plus 30 and be able to do that quite efficiently and just go to 79. Then they might say, I know I need to add 2 more, and I land on 81. So that's 2 different ways to keep one number whole. If your child is still working on adding one group of 10 at a time, that's fine. But sometimes they're ready to move on and start adding all of the 10s at once. All right, so that's not the only way we can solve. We have a couple more. So I want us to think about the same exact numbers up here, because we can keep one number whole another way. And I love this strategy. It builds on the first grade strategies between 0 and 20 that I posted, so watch that video. It's really important that students are thinking about those groups of 10. So let's think about keeping 49 whole again. All right, I'll draw it on the number line. I'm starting with 49 on the number line. I don't need to write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, all the way up to 48, 49. You can start at 49. That's something that we'll build towards as we start using the number line in the upper grades too. We don't need all the numbers, you're just right here. All right, I'm gonna hop on over to the hundreds chart. Sorry, this is the best way I could set it up. So I have 49 here. And what we really want students to think about is jumping to what we call landmark numbers. I made our landmark numbers in pinkish purple over here. So jumping to the landmark numbers is such a fun, easy strategy because they know their 10 buddies. They know what to add to a number to make a group of 10. So if I'm starting at 49, what do I need to add to make the next group of 10? Do you see how this is a group of 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When I'm at 49, to get to the next group of 10, I need to add 1 whole. Now, why in the world would Miss Conley tell us to jump to that landmark number? I'm going to tell you why. Because those numbers are easiest for us to work with. So, if we know 9 plus 1 is 50. Do you see the 9 plus 1? That's how we're getting to the next whole. I'm going to illustrate this with some other numbers too so that everybody gets what's going on. So 9 plus 1 gets us to the next group of 10, which is 50. From there, students know so far they've added 1. They still have 31 left to add. Students know this. They're breaking up numbers. Parents, it's so different than when we learned. They're just being so flexible with numbers, they can do this. So if they know I've added 1 so far, I have to add 30 more. They know 50 plus 30. They've been practicing that since first grade. So 50 plus 30, 5 groups of 10 plus 3 groups of 10 gets us 8 groups of 10. So we're at 80. And parents, we want to think about how much have we added so far. Oh my gosh, look at all these smiley faces I can draw because I'm using my landmark friendly numbers. So far, they know that they've added 1 and they know they've added 30. So far they've added 31. And if you ask them right now, how much more do you need to add? They're going to know 1 more. So, I just want to circle, I'm going to circle this as not the answer up here. But I want to show you we started at 49, we added 1, we added 30, we added 1. So I see my 32 here. I see my 49 plus 32, and my answer in this strategy is down here. If I wanted to finish this off up here, in my equations, I see the 32 here, I see my answer here, and your student, if they're using a hundreds chart, and please have them practice on the hundreds chart, they start to visualize it, becomes something in their brain that they never forget. So if they start at 41 and they say, I added 1, 10, 20, 30, and I need one more, that's how they would do it on the hundreds chart. Okay, so in this strategy, we still kept one number whole, but we broke up 32 in a different way because we were jumping to what we call those landmark numbers. Those landmark numbers with whole numbers are our friendly, smiley face numbers, the multiples of 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And in upper grades, we're still using those. Those landmark numbers are important to understand. Use landmark numbers with them. Get that word in your child's brain. It's really important. So that is when you're starting with 49. And I just want to go over what happens if you start with 32 because I want to make the 10 buddy thing very clear. We're jumping to landmark numbers using what we know about making 10. So, last example. We are going to start with 32 this time. I'm going to start with 32 down here. And then we're going to come over to the hundreds chart. A lot going on right now, I know. So, if I'm starting at 32 and I want to add 49, when I'm thinking about landmark numbers, I'm going to scan this row and say, I know a landmark, the closest landmark number when I'm adding is 40. I want to jump to 40. So I think about where I'm at. I'm at 32. And I want students thinking about the ones place and how many ones do you need to add to 32 to make a group of 10. So let's put 30 to the side for a second. We're thinking about the number 2, and we're thinking, how much do I add to 2 to make 10? And the great news is they practice this in first grade and in second grade. They know what's going on. 2 plus 8 gets me to 10, so 32 plus 8 gets me to the next group of 10. So they're using what they know about their basic facts to make a landmark number. So again, 2 plus what makes 10? They know 2 plus 8 is 10, so they know that 32 plus 8 gets you to the next landmark number. Okay, so what did we add first? We added 8. We're at 40. Students know they need to add 49 total. So they've added 8 so far. They're at a friendly number, a landmark number. Now is when they're going to add those 10s. So they might want to do it 10 at a time, plus 10, plus 10, plus 10, plus 10, plus 10. But we're moving them towards efficiency. If they are ready, they're going to make these jumps when they're ready to go to the next efficiency level. So if they're ready, we're going to draw a jump of 40. So far, I've added 48. I'm adding, right, this current step is 40 plus 40. They know 4 plus 4, so they know 40 plus 40 gets them to 80. So they added 40 plus 40. They got to 80. So far, they've added 48. They need to add 49. So they say to themselves, I need to add one more. Our answer falls down here. Where are our add-ins? The two numbers we're adding together. 32 plus 49 gets you to 81. 32 is here, plus 49 gets you to 81. This is your answer. This is where you see the add-in. 40 plus 8 plus 1 is 49. What does that look like on the hundreds chart that I really want kids using? 2 plus 8 gets you to 40. 10, 20, 30, 40, plus one more. Okay, so you notice I'm making those jumps of 10 on the hundreds chart. We're going right down because when we add a group of 10, the ones place doesn't change. Don't believe me? 42 plus 10, 52. 52 plus 10, 62. 62 plus 10, 72. So that hundreds chart's a really important representation. You can make them at home, scribble down several groups of 2-digit by 2-digit or 2-digit plus 2-digit problems and let them practice on the hundreds chart. We went over 3 strategies: adding by place value. So they added the 10s, then they added the 1s, and then they combined everything. Then we did keeping one number whole, where they keep one number whole and then break the other one up by place value. The last thing that we went over, and I did it in 2 different ways with each add-ins keeping whole, we kept one number whole and we jumped to landmark numbers. This is an important game that they play in 2nd grade on the hundreds chart called Roll a Square. If you want to Google it, you might be able to find a game board where they practice figuring out how far they are from a group of 10. So, if you have any questions, you can email me. It's connellymathathome@gmail.com. And I hope that this video was helpful. There is one also already up about the 1st grade addition strategies where I go over adding 10s and 1s in a little more depth if you want to read that first. These strategies are also taught in 3rd grade when we get into hundreds, and students start to tackle them at the end of 2nd grade too with hundreds. So what they learned about these numbers, they can start applying to larger numbers. They can still add by place value, they can still keep one number whole, they can still jump to landmark numbers. Okay, I hope you enjoy